time to get back to work. Coordinate plane, here we come. So this is a coordinate plane. It's a graph, all right? You might have heard it called an L graph before. It's got three parts that are relevant to us right now. It has an x-axis, that's the flat. It has a y-axis, that's the up. And where they meet is called the origin, all right? So we have an x-axis, a y-axis, and an origin where they meet. All right, those three vocabulary words matter very much. We are going to plot some coordinates, all right? The other word for a coordinate, we might call it a point, all right? We're gonna plot some points, all right? Or you can think about it like a dot, all right? We're gonna use a dot to plot some coordinates or some points. Every coordinate's gonna have three parts to it. It's gonna have a name, like a letter, all right? And it's gonna have an x value and a y value, all right? An x value and a y value, meaning, a little x there, a little y there, meaning, and I'm gonna write this down here, first over, then up, all right? First over, then up, meaning that first number tells us how far to go over, that second number tells us how far to go up. From where? From the origin. Origin is a fancy word that means beginning. So we start at the origin, and for our coordinate A, we go over 2 and up 1, 2, 3, and we put a dot. And what do we put next to that dot? Little a. That's where A is, all right? First over, then up. Now with B, we're gonna go first over 5. 1, 2, 3, 4, 5, and we're gonna go up 4. First over, then up. Let me see if I can do this. 1, 2, 3, 4. Close enough for B. Last but not least, on our first example board, we have C, all right? First over, then up. We're first gonna go over from the origin, over 3, and then we're gonna go up 0, meaning we stay on the axis. First over, then up. If 0 is in there, we don't go up, all right? First over, then up. So here, what do we got? We have an x-axis. We have a y-axis. They meet at the origin. Origin means beginning. In order to plot a coordinate, all right, or a point, we use the coordinate x and y. We go first over, then up, and we put a dot and a little letter. And now we've plotted three coordinates, A, B, and C. All right? I'm gonna get my camera reset, and we're gonna go on to the next example. All right, y'all, here is example 2. All right, what you'll notice is that it's much bigger, all right? Before our origin, we had an x-axis and a y-axis, and they only went in one direction. Now they're gonna go in both directions, creating a full coordinate plane. The x-axis goes forward and backwards into negative numbers. The y-axis goes up and down into negative numbers, all right? And what that does, we still have an x-axis, we still have a y-axis, we still have an origin where they meet. But they've created 4 zones, 4 sections. We call them quadrants, all right? And we give them Roman numerals, which is unfortunate, but it is. This is quadrant 1. It's what we were working with last time. It's the simplest one. It's the one you've been using since elementary school, probably. We call this quadrant 2, quadrant 3, and quadrant 4. So we would say right now that these red dots are in quadrant 1. If I put a purple dot down here, it's in quadrant 3. All right? So they all have a different quadrant or zone of the graph they're in. What we're going to do right now is we're going to take these 2 coordinates, all right? We're going to take these 2 coordinates and we're going to find the distance between them, okay? So I've already plotted them. I've already graphed them, okay? This is no different than before, but I've already graphed it for you. We're going to find the distance between them, meaning if I draw a line from here to here and I want to know how far is, and let's just get these points names. Let's call this X and Y. So how far is X from Y? It's a great question. How far is X from Y? First thing I'm gonna do, all right, and this is gonna look a little weird, but then it's gonna be like, whoa, it's gonna feel like, oh, this is why we're doing this, is I'm going to take this line and I'm going to draw a right triangle around the line. What do I mean by that? I mean that I'm gonna go like this. I'm going to go over and up. And I'm going to make a right angle right there. And once I do that, I've created a right triangle. So I went over. How far did I go over? 1, 2, 3, 4. And I went up. How far did I go up? 1, 2, 3. So I went over 4 and up 3. And I think you know where this is going. Now I can do the Pythagorean theorem in order to find the distance from x to y. We want to find the distance from x to y. Great. So we draw out the right triangle. We go over 4. Again, where did I get that from? I just counted. 1, 2, 3, 4. And we go up 3. 1, 2, 3. I had to count over here. It's a little tricky, but you'll get used to it. All right? And now I'm going to do the Pythagorean theorem. No big deal. We'll call this A. I'm going to do this kind of fast because we've been working on this for the longest. We'll call this B. All right? And we'll call this what? C. And we're going to come down here. We're going to do A squared plus B squared equals C squared. A is 4 squared plus 3 squared equals C squared. I'm moving fast because we've done this so many times. 4 squared is 16 plus 3 squared is 9 equals C squared. 16 plus 9 is 25 equals C squared. Run out of room, no big deal. The square root of 25. The square root of C squared. And so what we get, I ran out of room at the very end, but I did it. C is 5. C is 5. Wow. C is 5. So, there you have it. That's what we're going to do with this next step on this coordinate plane. We're going to have some coordinates. Either they'll be already on there or I'll give them to you. You'll have to plot them yourself. All right? Have some coordinates, and we want to know how far it is from one to the other. Well, what do? We draw the line, create the right triangle, all right? And then we do the Pythagorean theorem. I'm going to write those steps right here. Step 1, make the triangle, and then step 1, and then step 2, Pythagorean theorem. I told you it was the most famous math of all time. Pythagorean theorem. And wow, if you don't think that looks like smart math, you smarter than me, because that looks like smart math. All right. That's it. So what we're going to do now, what we're going to do now is we're going to go do some work, all right? And we're going to start. I'm not loving my hair today. We're going to do, first things first, we're going to talk about this stuff right here, all right? Just some basic plotting. Can you see it? Some basic plotting, all right? And then we're going to move on to this stuff, all right? So first we're going to plot, then we're going to move on to this. First we'll start in the first quadrant, and then we'll move on to all 4 quadrants, okay? And yeah, this is this week. Coordinate plane, Pythagorean theorem, and bringing it all together. All right, let's do it.